Hello everyone, this is my next bit of this signal injector, probe, whatever. I've received my PCBs, so let's have a look. This is what they should look like. Nice how I've sort of designed them. So I'll just pause and we'll have a look. Right, and welcome to my bench of many prototypes still in progress. Let's have a look at the PCBs. Right, so these are what I've got back, and let's just get one. And I don't know if I can get that in focus. They are small. Get my hand in. There, that might be better. Try it over here. Any better? Out, in. I think what I'm going to need to do is set up my microscope for these so we can see them better. But what I've done is, right, if I'll just get one of the batteries. So you remember these batteries, these little tiny batteries. You see this. Let's get it over. You see that that's the negative pole, and basically that's about 1 millimeter is that. And so what I've done is I've made these boards made out of 0.8 millimeter fiberglass, so they're really thin. And the idea of that was, so when the battery went in, you know what, I'm going to get my magnifying glass, get my microscope, because you can't see that, can you? Right, let me just set that up. There we go, you can see it now, look. The colour's a bit crap because of the lighting, but yeah, it looks like what I've done. Like I say, with these thin ones, I don't know. Oh yeah, no, they look really well. It's just I think it's just a shadow on there, isn't it? I was just looking. Where's my pointer? I was just looking down this edge here. Can you see? I don't think it's anything. Oh, actually, the solder isn't all the way out. The solder, that's where the solder finishes. But it's not an issue. That's not an issue there. And same here. The solder has sort of finished short of the edge there. But no. Well, when you see what I'm going to do, I'm going to change how the battery goes in. So if we get the battery, now just hold that there. You can see the battery going is going to go in between. I'll have to hold this up. Actually, I wonder if I can stand it on something. Oh, what I need is if that's 4 mil, 2 minus 1 is like 1.5. So it's like so if I stack. Yeah, if I stack these 3 thick, it should sit there. There you go. Stack them 3 thick. There, you can see where the pin sits now. In between there. I think I should have made this gap even smaller. Well, if I had made that gap smaller, then I could have reduced the overall width maybe. Like I say, you can see that we're now, if I push that way, you can see that there is the gap didn't need to be this wide for the battery to go in. It could have been a bit narrower. It's hard to see with it stacked because you're seeing the one underneath. Yeah, how's about that? Yeah, you can see that I could have reduced the gap a little bit. I was just a bit afraid that when I did this is the first time I've done one for this battery, so I was afraid I was going to make it too small and too tight, and then you'd end up filing and everything. But no, I think I can reduce it a bit more. I'll measure it, and what I'll do is I'll alter my footprint, so my footprint is right again. But yes, so we could have reduced the width. Let's just check the width. I'll just get my I've got some vernier gauge, vernier calipers. Let's see, get them in shot. Wing shot there, yeah. So yeah, I made them just shy of 8mm. The idea was that it'll go in through an 8mm hole, so 7.9 there. Just give it a little bit of a squeeze. 896, 895. Yeah, so as long as it's less than 8mm, it'll go in an 8mm hole, basically. And so that's brilliant. Yeah, so let's just have a look at the rest of it under microscope. So we can, we'll just view it all. So yeah, it looks really neat. I like it. I mean, you can't do this by hand yourself, so it's so small. But like I say, the thickness, it's only 0.8mm, and the idea is, what I'm going to do is I'm going to solder a plate across these. I'm going to solder a plate across these two terminals here. I'll solder it on one side, on this side, then I'll solder it on the other side, on the other side. And what I've decided to use instead is some of these, a bit of this plate. Right, I'll just show you what I get them off. So I have a kit. See, I'm in shot there. I have one of these kits for my DuPont, and what we have, and I'll just put that there, is, hang on, I'll just put my magnifying glass to the back and mess up the lighting. Yeah, so for my DuPont clips, when I make up cables, we've got these crimps that go on the end of the cables for the DuPont cables, but it leaves this this bit of metal. They're all held together by this bit of metal, and you sort of cut them off this metal, and it leaves this metal strip, and that's what I've used. I've used bits of that. It's not steel because it's not magnetic. I don't know what it is. It'd be some sort of imitation copper, chocolate sort of thing. Oh, it could be brass, actually. There could be brass. So let me just get my magnifying glass back, my microscope, I mean. Yeah. So what I've done is I've cut some little bits, and what I'm going to do is I'm going to I need to look at this. I'm going to solder one across like that on this side. There, can you see? I'll just solder it along. Solder it across oh, it's out of shot. There we go. Solder it across there, and then what happens is when this battery comes in, I've got it at a different level there, so let's see if I can just prop it up again. Damn, where did that go? There we go. It's so tiny. I need to keep changing my glasses over as well. Right. Yeah. Is that going together there? Can you see that? Yeah. So what'll happen is, because the PCB, the PCB is 0.8mm thick. This but the pin is 1mm thick. It's going to be a nice tight fit in between these two plates. So I think that simplifies it. And what I'm going to do for where, let's see if I can move it out of touch. This is a bit difficult. It'll be better once I've done it and shown you. That's if it works. Alright. So, and what I've done is I've bent some others. I don't know if I'm going to get this in and show you. Right. Is that inch? Let me just. I need to get the glasses. Right. So the other ones I've bent into that shape, and what they will do. Let's see if I can get this battery back where it was. And what they will do, I'll have one on one side and one on the other, and they will sit like that. I don't know if you can see that. Oh, I've got it slightly out of shot. There, sit like that, and they'll do the same thing. So this one will be soldered on this side, and the one on the other side will be soldered on this side, and that allows them it to sort of like. Trying to do that on camera, I can't do that. And that'll sort of sit in keep it, make contact, shall I say. So yeah, I'm going for that sort of thing. I couldn't be asked to draw it basically, so that's why I'm trying to show you it like this. Yeah, so I might draw it later on in another day. So I'm going to do that. I hope that was clear. Let me just pause and think. Oh yes, well, I'm just going to say my logo came out all right as well, so I managed to get that in there. From the width of this PCB is 8mm, so it's scaled down really well as that, and the text as well, and it's come out really good. So and then the other text, signal injector, and the arrow. Yeah, so that is all. That looks all nice, and it looks just like what I drew in KiCad. So yeah, I'm really pleased with that. That's a good PCB from PCBWay. Yeah, oh right, yeah, tell you what, just to make it clear about the 0.8, let me just get rid of the microscope again. Bring back my, let's just get rid of that out of the way. I don't think I need the well, yeah, I'll bring it back for when I'm doing some soldering actually. Yeah, so what we got, put that between there and, alright, so it's 0.85. Well, that'll be down to all the lacquer, well, you know, the stuff, but generally it's 0.82. It's not a problem. Where it sits at the back, that's where the pin's going to go. It's less than 1mm anyway, so that's all I need. But yeah, the reason I changed the originally I was going to go for, hang on, let's bring the picture. Yeah, so as you see, I was going to go for this like wire affair. I thought it looked really neat, and the actual wire I've got, if I don't know, maybe this needs the microscope as well, but basically when I put the wire in, hang on, I can't see it. Right, yeah, so in these ones where we've got the really fine, actually let me just bring the microscope back. So let's just see if I can get that to show what I'm on about. Microscope, there we go. Yes, so the wire would go through, and I would stop it about there, sort of thing, and then I would bend this side over. But when I try, but I thought, hang on, let's try and get a bit of focus on that. Where am I? Here. Yeah. So just bending the wire, because I think it's just because I'm a bit scared of it, really. But I think if I tried bending this wire, I might snap the PCB with it being just 0.8mm thick. You know, trying to bend this. I don't know if you can see the PCB bend there. If I try bending that wire around my thing, I think I'm going to break one of these tabs. So that's why I've gone the other way anyway. What I might do is I might experiment with one of the other PCs, because obviously you can get 10, which I forgot to do. Yeah, right, I'll just pause and think again. Right, normally when I put this can't come back. When I put when I do these small pieces, what I normally do is I put all my components in an old pill tray, which is little disc components. But there's only a handful here of components, so I've stuck them on this bit of paper. The only thing about having it on a piece of paper is you just have to knock it and they've gone everywhere. So so hopefully through this video I am not going to knock my piece of paper, and these are going to stay where they are, so I know what's what. But I'm also going to try and do another experiment as well. What I'm going to do is I'm going to just blob the little bits of paste on here, and just scoop some out of here. But what happens with this? It tends to dry up. I've got. Where are we? Can we get that? What's it called? Oh, is that the name? God, you can't see that. I think the thing. Oh, there we go. It's called mechanic, but a solder paste. I don't know. It's more like for car mechanics, I think. No, seriously, it works well. The thing is, though, over time you don't use much, and over time the paste in the thing, because you've taken the cap off and broken the seal, the liquid part of it tends to evaporate, and it sort of gets dried up. So what I'm going to try and do is use some of this iso alcohol stuff, and I'm going to try and just thin a load down and see if that works. Actually, I think what I'll do is, because it's all minute, this, I'm going to get the microscope back. Just give me a minute. I'm going to set it up. Right, so on my bench I've got I've got this little bit of hardboard there, and I've got my paste, and I've stuck the thing here, and I'm going to use my little knife and see if I can just get some thinner stuff. So let's just bring more of this into view and see if I can get it on camera. So like I say, I'm going to use very little. There, so that's a right tiny bit. I think that's way too much, basically. There, I'll put my knife next to it. Right, that's my knife, and it's just a really tiny little bit. We don't need much at all. and so what I'm going to do is just try and make that into a bit more fluid, really. Going to add my can I get that in there? Yeah, get my bit of ISO. There. Right. I'm not going to keep looking at my screen. I'm just going to try and keep looking at what I'm actually doing, and hopefully it all stays in shot. So I'll put some ISO on there and we'll just give it a stir. It was only a few drops, but hopefully you can see that it's all running into it and making it, yeah, that's what do they call this? Cutting? Yeah, let's cut the yeah, I hope Google, I hope what is it? YouTube doesn't search for special phrases. Yeah, we'll just use a razor blade and we discuss. No, but it might do. You never know. So, and just right. So yeah, that seems to. I tell you, it was just a few drops. I didn't put a lot on there. It was very little. But yeah, stirring it all in. I mean, this is just an experiment. I'm just pissing about, really. But you never know. It might saves throwing it all away, doesn't it? Because you can't spread it. Yeah. Oh, this is coming out nice, is this? I think if you just keep chopping and mixing it, and just wait for some of the ISO to evaporate, you'll get it to the thickness that you want. Your consistency. In fact, what I should really do is maybe get a because it's nice and thin. I'm gonna do that. What I'm gonna do, I've got some small syringes somewhere. I'm going to dig them out and see if it'll suck it up, so then I can push it out with a syringe, because it is really nice and oh yeah. If I can put that down in its little blobs, it'll be great. Yeah, right, just give me one moment. I hope that was all in shot as well. Right, so I've got some of these small syringes. I thought they'd come in use. And I've also got some of these little, God knows what they're for, these little needled things. I know what we're using them for is for putting solder paste on, so get that in shot. I've picked out two. Let's put it that way, see if I can focus on it. There. So there's two of these. These are two little sizes. These are tiny little things, but we're doing tiny stuff, so let's give it a try and see if I can suck it up in the syringe. Right. What we'll do, let's go down onto there. Does that look better? Right, so I'll try the thin one first. Oh, damn. 1 minute. I forgot to put my microphone on again when I went down to find the syringe and what have you. So yeah, as I was showing before earlier, I've got two sizes. Let's bring the microscope back. There we go, that's looking at that. So if I put one of these down here, so I've got that size, and I've got that size, it's a bit bigger. You can see the hole in that one. You see the hole in this? Yeah, sort of. So I'm going to try the small one first and see if it'll suck up. So I've stuck that on the end of the little syringe. So my little syringe and see how big that is compared. Well, look, see how much solder paste I've done. It's just little tiny amounts. So let's just see if I can suck it up. Yeah, I think if I just need 3 hands. If I got I'm still in shot, I hope. Yeah, it's going up the small one. Well, if I can suck it up then I should be able to squirt it out as well, shouldn't I? That's the theory. Let's try sort of. Am I going to stay in shot there? Let's just bring that back. Well, I'll tell you what I'll do. Right, you've seen me do it anyway. What I'll do is I'll just pause it so you don't have to. Well, it's going to take me a little while just to suck up every little glass drop. Okay, I pressed the wrong button for pause, but hopefully let's continue. I've got the. I hope I haven't missed the filling out. Right, so yeah, I've got my paste in my little syringe. Let's see if we can get some paste onto the pads. I'll keep the microscope so that we well, you're not going to see otherwise, are you? So yeah, I should have had a bit. Shame I don't have a bit of bigger worktop so I can spread things out a bit, but anyways. Right, so I think we've got. I wonder if we can get some better colour if I turn that light off. Doesn't it look better? It sort of gives a bit more. What would we say? Contrast, I think. The extra eyes fell off my glasses. Yeah, so see if I can just focus it a bit better. It's only a cheap microscope, but you can see. Right, so let's see how well I do. No, I'm going to turn the light on because I can't see what I'm doing now. It might look good on camera, but I can't see anything. Right, so it's going to have to be like that. Sorry about that. I need light to be able to see what I'm doing. In fact, I've actually got a big magnifying glass on the light. Right, let's hope I don't knock it out of shot while I do this. Oh, that was a mess. Right, well, let me just clean that off. I really messed that up, didn't I? Oops, sorry about that. I was just trying to blow the crap out of the hole. Right. Let's try again, shall we? Right. We have that in shot. This time we have I think this is primed now. Let's give it a go, see what happens. One blob. Oh, I need to, wants me to squeeze this really tight, that. Have I got enough in there? You know, I don't think there's enough to squeeze out. Right, I'm going to mix some more, the same amount. Just give me a minute. Yeah, basically, I've got it shoved all the way in, and all I've done is mixed enough to actually fill this thing. I told you I was only doing a little bit, but basically all I've done is fill this thing here and just got one little blob out, so I'm going to have to mix the same amount again. So just remember, you need enough to fill your syringe as well. Right, one moment, be right back. Right, I've got it. I've got a bit in the actual pipeline now, in the actual thing, so there's only, well, I don't know if you can see that, but there's only a little tiny bit. But anyways, I basically mixed about the same again. So let's bring back the microscope. There we go. So we've got one pad done. Let's see if we can get the rest. Right. Oh, I need... Oh, too much. There's a little drop, and a little drop. Far too much, I think. Right. Let's see. Oh yeah, go all the way up to there. Right, drop. It's like making cakes. Put icing on a cake, is this? There we go. Getting better as you go. Right, only tiniest drops. Right, I'm just putting a very tiny drop on these. I'm not going to put this. Well, yeah, might as well. I wasn't going to put it on. I've got another little trick I wanted to show, but I don't know if I might leave it till the other projects. I'm doing a little project for servos. I'm going to do it with that one when I do that. So yeah, the other trick I'll have to wait for that. Oh, I think I've gone out of shot now, haven't I? Right, let's just turn that around so you can all see me do the other bit. Is all that in shot now? Right, I'm not doing. Oh yeah, I need to do that. Let's get back to see if I can get. Oh right, so there's the ones I've just done. Right. Have I just knocked that out of the way? No. Right. Yep, one little drop, another little drop, and a little drop on here, and a little drop on there. I wonder if I can suck some off, because I've put way too much back here. Let me just spin that around so I can show you what I'm on about. Yeah. can you see that first one? It's a bit hard to tell with this light. That make me light. I haven't got the best lighting. Well, it's a desk lamp. Right, but basically I'm going to see if I can suck some off that one. Oh yeah, I think I have. Yeah, I suck some off that. No. Yeah, suck it off. No. Yeah, don't put that in. Don't cut that and paste it somewhere. Right. Yeah, so let's move my light. So that is all the little things pasted with little blobs, and basically, I don't know if you can. Oh, I've stuck that in front of the camera. My light. There we go. So yeah, I did all that with the. Am I inch? Where am I? There we go. So. Oh, we don't. Well, I'm going to leave the microscope there because I'm going to put the. I haven't knocked all the components all over the place yet. But yeah, so that is that little tiny syringe there, and I sort of watered down the paste with the iso alcohol stuff, and it seems to work a treat. So we'll see how well it goes when it comes to soldering, because I'm going to do it on a hot plate, and let's add the components. So, well, actually, what I'll do, I don't know. I wonder if I can get that. If I can get the. Well, I'll tell you what I'll do. Let's see if I can. What I want to do is try and get this into focus. There, something like that. That'll do. And then. Yeah, let's just. What I'll do is I'll just make that smaller. There, like that. Yeah, stick that there. There we go. Give it a bit more width. If I give it a bit more width, I can just zoom in a touch and focus on what we're working on. Yeah, so we've got C3 there, so I want C3. Let's see if I can stick C3 in the right place. With all my lights and everything. Let me just gently move this to the front. I'm going to mess it up, I know I am. Right. What did I say? C3. Oh, yeah, what I also do is I have this... I use this online bill of materials. It's a bill of materials which I make from KiCad. Basically, let me just bring that up. I'd like to show you. So if we get KiCad. So we've got KiCad, and I've done all my circuitry, and I've got this plugin. Basically, it generates an interactive HTML bill of materials. And you just click it, and then what it does, it creates this, and you can have boxes. You can customize all this stuff, but basically I've sourced everything. So like so, and when you're sourcing stuff, you can actually have it highlights. So when you've sourced stuff like that, it highlights everything that you've done. So as you go through and source it, it'll put everything green, and we can have it on placed as well. So what we can do, if we take C1 there, which if I just click on that, that highlights where C1 is, and I can place C1, and then once I've placed it, all I do is just tick it, and it turns it green. So I wonder if I can stick that up there. Move that. Yes, so we've got our. We only need the front, so we'll have the front. I wonder if we can zoom in. Right, let's zoom in as well on that. So you can zoom in, and we're selecting C1, which goes there. Well, actually what we want to do is let's work from the end, because then we can see what's happening on the microscope. Can I just focus that a bit better? It is a little bit out, isn't it? How's that? That looks better, doesn't it? Yeah. Sending me eyes back of my head, that was. So let's go for C3. So what we want, so if we get untick that, we haven't done that yet. We want C3, which actually there's a C3 both ends. So can I get both them on shot? Right. No, I'll do that one first. Okay, C3 and 4, because they're both the same value. Well, actually, I've put them in separate squares, so yeah, no, sod it. We'll just go for C. Well, actually, when I tick it off, I haven't separated them. You can actually tell it not to keep them all separate as well. I think that's in one of the settings. Is it? Continuous. It might be when you create the thing. I don't know. Let me just think about this. Bad tilt screen, that continues. I wonder if it's... Oh, ungrouped. Does that do it? Ah, right, yeah, so there we go. We've ungrouped, so we've got C3, and then we can go to C4. So, yeah, let's do it that way. So, it's like I say, you can do all sorts with this thing. So, let's put C3 on there. So, grab it from here. Move it close. Is that close? Oh yeah, that was in shot. My glasses have fallen off. Tell you, I'm blind as a bat. Old man, blind as a bat. Right, so let's get that one in. Like I say, now I've put it on there, you can see that there's way too much here. Hopefully you could see that there's way too much solder on there. Right, so, that's placed. So let's tick that off. And let's go for C... No, go for R4. Where's R4? There's R4. Yeah, let's just work our way down, and then we'll tick that off when it's done. So R4. Pick that up, R4. And this is where you see that I really a bit alright, you can't see that. I've put it close. Let's just there. Right, let's just move me R4 closer. Can we see R4? Right, yeah. You see which way up it is? You've got the writing on it. Well, yeah. If it was the other way around, I would have turned it round, but it's the right way around. I want it. I'm really picky about these things. I just can't help it. So the writing's the same way as the writing on the PCB. There we go. Like I say, once you start putting them on there, the solder will start drying up, but you only needed it liquid while you actually dispensed it. So right, yeah. So that was me R4. Let's go for D1. Where's D1? D1's there. And we want the arrows pointing this way. This is one thing you've got to get the right way around. So I'll just put that close. there. I don't know if you can see there. Can you see there's like at one end there's a bit of a green tinge to it? That's the what you'd call the black band on a diode, or the arrow pointing. It's the bit that goes across. If I turned it over, you'll actually see even better. Let's see if I can turn it over for you. Oh, it's out of shot. There, that's the underside. You can see that it's a bit squarey, but you can see it forms like an arrow, and so the straight bit isn't the big long straight bit isn't the band. This is the actual arrow. You got to imagine it fitting in the arrow of the schematic. So I've got it actually pointing in the right direction at the moment. So this is like forming an arrow like that, and this band around here tells us that the arrow points into this bucket. Let's call it a bucket. I don't know what you call it. The silk screen. It's open at this end. Arrow. Just remember, arrow goes into inside. It goes. The arrow goes in the direction you're going to go inside this silk screen. There we go. Load of crap, but you know, it's one. You remember it one way or another. Remember it whichever way you like. But yeah, let's turn that over, and so it goes like that. So that's D1 in place. Alright, I can move that up a touch. There we go. Where was we? LED's done. We're going for R3 next. This one. There. So let's pick up R3. Oh, yeah. Any eagle-eyed people will see that some of these resistors are not what it says. I am experimenting with frequencies. Like I said before, the values of these capacitors and resistors can be, well, one capacitor and the resistor can also change the frequency, and so that's what I'm doing. So if you noticed, oh, this one is the 1.5K, which is correct, and actually I've got it the right way up as well. So it's there we got 1501. So let's take that off. Let's go for C1. There we go. Yeah, well, you can't see what I've written on this because there's nothing written on this, so it's just C1. I can tell you it's not what it says on there. I may be changing this again. Oh yes, that's it. Yeah. All right. I must try and remember. There's something I want to mention about my my work of art, my prototype work of art, and it's pretty important actually, because I think I screwed up a little bit. Yeah. So that's C1. So we're going for C2 next. Yes, I found out why I got 50 hertz. Well, yeah, it is 50 hertz in UK. Is it? I thought it was, yeah, 16 states, isn't it? Yeah, so that's C2. My memory. C4, Right, so we've got C4. Yep, let's try and blow it up with a bit of C4. There we go, that's C4 in its place. Oh yeah, they're way back there. Right, let's just move that down a touch. Because it's not going to fall off. Oh, actually, I can get R1 and R2 in. I can get them all in. There we go. Yeah, so let's get the IC in there. And oh right, yeah, so where my mouse is, I don't know if you can see this little arrow here. There's on the silk screen. This shows you that this area is pin 1. If we look on the bill of materials here, you can see that there's a little tiny arrow there. That's indicating pin 1. I think you can actually... Where are we? Oh, somewhere here about pin 1, I think. Can't see for looking. Nope. Tell you what though, what's that board rotation there? Oh, look at that. Hang on. Yeah, I should have done that. There we go, look, it looks exactly the same now, doesn't it? There we go. Something else I've just learnt with this Ace. It's fantastic bit of kit. Yeah, so anyway, there's pin 1 and there's pin 1 up there, look, so we just make sure we get that the right way around. I'm sure there was something about highlighting pin 1, but anyways. But besides that. Right, so which way around have I got this? There, pin 1. Right, I'm just going to move this to line it up. Don't know if I've got it in shot. Have I got it in shot? Yeah. I'll try and keep it in shot this bit. I just need to have a look around it. Oh, I've just stuck my fingers all over bloody solder paste. I don't know if you can see it. I've just flattened these two out with my finger. Alright. This is because I was trying to line this up. Yeah, I've got another technique for putting dip type pieces on. Right, so yeah, I totally messed that up, didn't I? Right, so that's the ground there. Oh yeah, so that's where my switch goes. Right, hopefully the solder hasn't dried up in my syringe. No, it hasn't. So what I'll do is I'll just put another little blob on here. It'll all pool up once it's all got hot, but I just want a little bit just for the solder to stick to the switch. Right, so I've got the... Which way, have I got that the right way around this time? Have I just... What am I looking at there? Oh no, that's right. Oh right. Oh, I've missed done resistor R2 and R1 yet, have I? Silly me. There we go. Getting carried away. That's what happens when you stick your finger in stuff. Right, so I've done the where is it? That one? Yeah, I've done that. Now we're going for R2 and R1. So R2, which is there. Yeah, and of course, if you don't want... Oh crap, oh no. Hang about, I've lost R1. Right, oh there it is. Hang on, I'm going to get both of these under the microscope so I can see what they say. Right, I think this is R2. Right, can I see what they say? Oh, they're both the same anyway. Yeah, you can see that R1 and R2. R1 says 10k and R2 says 100k. I'm putting 10k's on both here for a test. I want to do a test on this at a different frequency. I'm trying to drop the frequency right down to do something other than input some noise into the circuit. So yeah, I'm putting two 10k's in here at the moment. So, but these are the two resistors that alter the frequency of the 5-5 timer. And I've got one of them wrong way around, haven't I? Yeah. I like them all the way up. Sorry, guys. I do like them all the right way up. There we go. You can tell me I'm a ready idiot for doing it, but who cares? There we go. So they're stuck in place now, and we take them off. And we've just got the switch. Let's put the switch on. Yeah, the switch I've got is tiny. The reason I've got loads of different switches. What I did was I was looking on eBay for little boxes with little compartments, you know, the little components. And I don't know if you ever looked for little boxes for holding little bits and bobs and stuff, but they can get pretty expensive, you know, when you start filling them up with little compartments and stuff. And what I found was a box of assortment of switches cheaper than it was to buy a box. So I bought the box, the switches for the box, and thought. And then when I got it, man, I thought to myself, well, where am I going to put the switches? So they ended up staying in the box. Anyways, right. So let's go on to let's zoom in on the main screen. So what we've got is our little thing on my hot plate there. After the legs are plastic on here. On my microscope, the legs are plastic, so I'm going to have to move the microscope for now while I put some heat into my hot plate. So I've got my hot plate plugged in. That's how hot it is here at the moment. We're at 28.8 degrees C. It is warm for me. Normally we're down to usually about 20 here, but we're at 28. So let's turn it on. So what I usually do is I haven't done one with the 0.8 millimeter thick PCBs. It's thin stuff. I don't know if I'm going to cook it, fry it, or what. Let's see if I can get some focus on there. What about there? Does that look better? I wonder if I can put my microscope. Yeah, it'd be nice if I could put my microscope on the other side. And then you can see it all melt, can't you? Let's just move this across. I'll pause and get it all set up. That's about the best I can do. Oh, you can't see this. Damn, hold on, you can't see the screen on the hot plate. That's about the best I can do. I need to be close with the microscope, so I can't get a lot in shot. It's not that much, but I just wanted you to be able to see the paste as it melts, because after all we've mixed it with the iso alcohol, and I just want to make sure that there's still enough solder to cover the pads. So we can see that we're at, well, oh, it's got a little bit cooler, 28.3. Yeah, so what I first do, right, I've propped up the microscope with the paste. Now the paste I have, it says 183 degrees, but the thing is with these what was it, PCT, I think it was, these heater plates, anything you heat up, you can heat up really quick, but you can't cool it down quick. It takes a while for the heat to dissipate. So what you have to do when you're using a hot plate like this one is you have to take it up gradually and let it settle so that the little chip can what's the word I'm looking for? The chip can do its maths and keep the temperature constant. Anyway, it'll come to me in a minute. So what I usually do anyways, what I'm saying is I usually take it to 100 degrees first, let it go up to 100 degrees. It's going to go past 100 and then settle, but the thing is, it's like you've got a really fast car going down the road. If it's got some shit brakes, it has trouble stopping, but you want it to stop at a certain point. You've got to sort of you can't go there too fast, otherwise you're not going to be able to stop and slow down, are you? So it's the same when you're heating up the hot plate. So we can see that we're 100, well, it's overshot by what, 10 degrees, 11, 12, 13, still going up. But you can see that the paste is drying out now. So all the ISO and the other stuff that was in there to make it fluid while you applied it to the pads, that is all dried out now at 123 degrees. So I'll just let it settle a bit. Once it starts coming back down again, then I know that the PID, there we go, I've just remembered, the PID is now getting control of the temperature. So what we can do is, before it drops it down too far, we can take it to 150. I could, of course, tell you some bullshit and say that this is all to do with the flow chart, but it isn't. It's got sod all to do with that. It's but what I will say that 150 is a temperature that is kind on the majority of components. You would normally take stuff to about 150 if we were talking about flow chart for the heating. 150 is like a safe temperature. Nothing sort of melts at 150. Nothing sort of gets damaged, and some delicate components will take 150 okay. But you can see that we shot over to 160. But we know that, I know that the solder wants to go at 180. 187 I think it said it was. So our next step is 200. Now it's going to go way over 200 and then drop down again and stay steady at 200. But this should then, this next step should pool all the melt the solder and pool the solder. And what I usually do is I take my my little little knife, or I might even take the tweezers. Get the knife and tweezers ready, because if you haven't got a really nice flat bed and the thing's not totally flat, you're not going to get a nice even contact on between the PCB and the bed for the heat to transfer through. So sometimes what I'll do is I'll push it down in places. Now with these things, the heating element is in the middle. It's a rectangular one, but it's about this. Well, actually, it's about as long as the piece we've got, and it's about this wide. The rest of it will get warmed up as over time, basically, as it sort of settles down. So my next step, we can see that now we're now settling at 150. I mean, we can quite happily leave it there, and it shouldn't damage anything. But I'm going to take it up to 200 now, and it's going to overshoot and then drop down. And in that time, I want everything to flow and be right, and I want to be cooling it down soon after that, because we don't want it at 200 for too long. Yeah, so put it up to 200. It's now going to go up to 200. It'll overshoot, give us a bit of melting on the solder, so probably about 210, something like that, and then it'll start dropping down again. But in that meantime, all the solder should melt, and we should be able to just make sure that everything's lined up and everything. Most of the stuff should just float on the solder. Well, I was going to go in there with my oh, there's a bit just there I can see on the microscope, but can you see where pin 1 is? There's pin 1. Oh, that's on the other side, I can't get to it. What I might do is I might clean that out later on, just scrape it out, but can you see it ain't quite pulled up right. Let's just see if we can get it in there. I think it's alright. I think everything is just, I think it's all just gone. Right, I'm going to turn it off now. So I'll just turn the heat off. I'll just see if I move it around on the, so you can see it on the microscope. You can see that we've got a little, well, get me a mouse, we've got a little bead there, but this will just pluck off. Oh, there's a bead there as well, and some beads. All these beads should just sort of like disappear when we put the iso alcohol. The only thing holding it on there, that bead, is the flux, and so once we dissolve the flux, that should come off with it. Oh, hang on, I'm trying to move it around with my mouse. Can't do that. So let's just have a look at the other end. Yeah, the switch looks fine. I haven't soldered the battery thing, and we're going to come back to that, and I'm going to do that in my hands. So what I need to do now is just take it off there. What I do is I will just move the microscope. I'll just do it live so you can see what I actually do. I have let's just click on this as well. Yeah, so that's it. So what I have these 2 bits of wood, usually, because sometimes it's a bigger board and it'll span out a bit, but with this board I'll just put the 2 bits of wood together, and we'll just pick up if I can. Just pick it up and just stick it on the bits of wood and just let that cool down on its own. This is going to take, the actual hot plate will take forever to cool down. Like I say, you need a fan on it or something to dissipate all the heat, or some block or something. Sometimes I might put something like this on. That's a big lump of lead, is that actually, and that'll just take a lot of the heat out. Is it dropping down quick now? It's at 52, 151, 150. See if I take it off, it'll... Oh, that's warm, is that? Yeah. Yeah, it'll slow down now because there's nothing actually cooling it off. Right, I'm just going to pause while I just let that cool and get rid of it. Okay, here it is cooled down and cleaned up. A lot of people would tell you to use a bit of ISO on it, a bit of a brush. Yeah. Well, forget the ISO. I use that occasionally to do things. But to clean that up, the best thing I do is take it to the kitchen sink and use a bit of fairy liquid and water, and still give it a brush with the fairy liquid, but that's far better than using ice or the iso alcohol. It gets rid of a lot more shite, and it comes out really nice and clean. So the next step is just to check the work, and I use the the microscope, but I do this by hand and just lean back and sort of hold it in my hand and just go over it really and scrutinise it. So that's my next step. Let me just set it up. Oh, before I just check out my my board, what I want to do, I just want to mention something about the these cheap little USB microscopes. Some people think they're crap, and usually it's because they've done something and they don't realise they have done something. There's like a fixed focal point here. That's what this clear plastic bit is. Is to give a fixed focal point. But what people usually do when they're using them, let me just move that. Yeah, so they use them and they use them like this, and they look at the well, let's just put it flat. Right, so we're looking down, and I'll get it the right way around, so I know which direction I'm going. So we look on flat, and we look at on the PCB, and you can see. Let's go where the diode is, and you focus in. So you move the focus wheel. I've lost the diode. Right, so we can focus in on that diode like that. There you go. Everything looks fine, doesn't it, really? But what you don't realise is that there's two focal points on these things. If I keep zooming in, see, it goes out and you think, oh right, go back again. So go back again. But no. If you zoom in further, keep going, and keep going, you'll eventually hit the second focal point. And now you can see the actual bit of diode in the middle there. Look, you can focus on that. Can you see now that we're really zoomed in to the numbers that they say that these will multiply something to? Let me just, I'm moving that out of it. It's right on the edge of the thing. Right. I keep slipping off the. We're zoomed in that certain. We're zoomed in so much now. Hang on. I've lost it now. There we go. Yeah. There. So there's the diode, and where the LED, shall I say? There we go. So you can actually see a bit of wrinkles on the bit of plastic, and then you can see the little chip inside. And as I say, if I now just zoom out and just keep zooming out, this is where people normally think that it should be focused at there, you see, but it isn't. It's a second focal point, and things look smaller than what is claimed on the paper, and people go say, oh, it doesn't really zoom in that far. But it's because people don't turn the wheel far enough to get it to the proper focal point. This is not actually the proper focal point. Anyways, but this is the one that I use for viewing. So I am just going to pause a minute and just get myself relaxed. Okay, so I'm just going to examine my PCB with my microscope. I'm nice and comfortable. Got them held in my hand so that you can't see on shot. But what I've written this little application because I didn't like the one that you get with the microscopes. And what I've done is I've put a thing on it, a negative, which I find quite useful. And it creates a negative of what you're actually seeing. But I could put that in another window. So if I open that window, we can see that these look a lot different in the in negative. And right, so if I double click, get rid of that, zoom out a bit, we can actually have both windows on. There we go. And you can see that you can actually get a better view of what you're actually seeing. Sometimes in the normal picture things will look okay, but sometimes some things will stick out better in a negative view. So I'll just wander through, and sometimes I prefer the negative to the positive. But you can see that they're all nice good joints. That looks like a bit of a blob, so what's going on there? Oh, obviously I've put too much solder on there, haven't I? Yeah. Never mind. Let's go a bit further. I've gone out of focus. Yeah. No, so you can see on that first resistor there, on the negative you can see a nice black spot. Although it is spottable, you can spot it on the positive, which is a silver spot. There's a little bit of a solder ball there that'll just pop out. It's just stuck in with the flux. I usually go around with my tweezers and just poke it out, but you can see. And I find that these are far better for looking at in negative as well. You get better perspective, more contrast between the two things that you're looking for, and so everything looks fine. It's just an added feature that I added that makes it easier for me to see things. But so far everything looks pretty good, and you can see that I didn't really need to use a lot of solder as well. Look, I mean, there's plenty of solder on these things. You can see that there's plenty of solder. That's the trouble with these small components. You just need to look at it with solder, and it's covered. So yeah. I think most of that muck is from the rag I used to clean it. But yeah, there's a few little bits. But yeah, that looks fine to me, I think. I can't see anything really wrong. What I tend to do is just go down the side there and just scrape it a little bit with the with my tweezers, with a sharp point, a needle or something, and just clean all them bits out where all the flux is. Or totally soak it in iso alcohol to get rid of all the flux. But yeah, that looks fine, so I'll just close that up. Give me a moment. Alright, now I'm going to attempt to solder the the little plates for the battery on. Let's see how this goes. I might as well use what's left in this syringe of solder paste, so I'm just going to use my soldering iron to do this. So here we go. Right, so there's a bit of solder. Now I'm not sure which way to do it. I think I'll do it this way. So hopefully what'll happen is all the flux will go through that hole and make a right good bond. But anyway, that's sat down there. And what I'm just going to do, just clean up my tip. It's full of shit at the moment. And I am going to see if I can just solder that in place. Actually, I'll just put a blob of solder on the iron. Yeah, just put a little blob so we make good contact. There. There's a little bit of solder on there. And let's just try and... Oh, no, hang about. Right, okay. Hang fire, right, okay. The other thing I was going to talk about, right, let me just... Yeah, I'm going to use these now then. Normally, just a bit of sidetrack, normally what I would like, doing something like this, can you see those chips on there? I would do them separate to, I wouldn't do them on, well I would do them on the hotbed, but what I would do is I'd do the soldering, I would solder them on separate, and sometimes I might want to do them with a soldering iron. Now, the thing is, it's keeping them held in the same, the correct place. And what I've come up with is these, right. You always look to the women. Right, there, can you see them? Hair clips. These are little clips for women, put the whole hair. They've got like a flat band, but what happens is they've got this curly bit, and the hair goes in between and it holds the hair in place. Well, yeah, cheap and cheerful. Just get some of those, okay? And what the pretty, they have the shape for doing the hair, you know. So this one's curved, this one's flat. But what you do is you reshape them to suit yourself. So what I've done, I'll just put them two back away because I don't use them. And what you do is just, you've got your flat one, and then just reshape the other one straight with a tip on the end. I don't know if you can see that. Can you? Maybe see the end there has a little point on it. And basically, these, I mean, basically what you've got now is a long crocodile clip. And what you can do is you can reach in and hold your chip in place, you know, because it's flat on this side, but this will reach, this side reaches over, I've got that in focus, reaches over onto the chip, and it clamps it in place while you do your soldering around it. So that's just something I thought I would just share with people, just to, you know, things are out there that can be repurposed to do something else, and that's what I've done with these. So yeah, so I've got this clip. Let me just bring my oh, it's a bit out of focus. My microscope. Got it wrong way there. Is that better? Gone the wrong way, have I? Doesn't take much to doesn't take much to put it out of focus, this. Like I say, cheap and nasty. There we go, I think. Oh, that looks good. Yeah, so there's my clip on there, but to hold it in place while I solder it, there we go. Just put that little clip on there. I can move it to where I want it, and then when I put my soldering iron on it now, it's not going to move. Oh, that could be a bit straighter, couldn't it? Yeah, let's get it straight. Looks like pissed as that, doesn't it? There we go. Oh, there we go. Is that straighter? Yeah, that looks straighter. So now I'm not going to really move it when I put my... Oh, turn it on. Put my soldering iron on it. Let's just give that a little bit more... tiny bit of solder, just so that it... don't take long to warm up the thin PCB. No, that's one done, so I remove the clip. Let's turn this over. Put it in that way. Have I got it in shot? No, I haven't, of course not. There we go, so there's the underside. So what we'll do is we'll just put this one on. Oh, I'll put a bit of the what is it, solder. That side this time, and then I will just put this one on there like that. And the other thing about these clips as well, they act as a heatsink, so if you've got some delicate components that don't want too much heat in them, these will take the heat out. So win-win, so to speak. Let's see if I can solder that in place. I'll get round my can't get in that way. Camera's in the way. Camera in shot. How can you? Let's put a bit more solder in there, so it's not reaching. There we go. Right, let's just test that piece out and see if it worked. If it did what I expect it to do. So we can take that off there. Take that off there. I don't know if we can see. Can I get that into the shot there? Get it down the end. An end view. There. Can you see that we've got the metal one side and the other? And what we should have. See if we can get it in focus. Yeah. So this tab is soldered on this side, and the other tab on the far side is soldered on this side. So these should actually be able to spring up when the battery is inserted. Now, can I get that inserted on camera? That's out of focus. That's in focus. So that, oh yeah, it's a tight fit. Will it go in? Yeah, it squeezes in nicely, does that? Get it in focus. Yeah, so that has squeezed in there really nice. Oh, that's come out better than I expected, is that? There. So that is a tight fit. Can you see? So that obviously it's going to lift this side up on this side, but it'll also lift this side up on this side. Or have I actually soldered that down? I don't know. Anyway, one of them moves, so one acts as like a bit of a spring for it to push in and out. So that there is a nice fit, is that? Oh, hang on. You can see it below, but see if I can get it on me camera. It's the trouble with things being so small. Yeah, there we go. Yeah, that there. It's a nice snug fit. I'm trying to do this and keep it on camera at the same time. There we go. Out, up, and in. There we go. It's a good solid fit. So now let's see if we can do a good job with the other bits. God knows how this is going to go. This will probably go totally tits up, I would have thought. Anyway, let's see if I can just get it in shot first. Right. Oh, can you see? Can you see the? I don't know if you can see there, but you see that hole? How it's distorted? That's the damage I did trying to put the wire and bend the wire. This is what I was a bit afraid of, using the wire, because you know the wire is stronger than the actual PCB. So, anyways, let's see if I can balance this. So I want that to go on there. Like that. Nope, where'd that go? I can see one of these going on the floor. I just know it. I don't know whether to pause and do it and then let you see the result, or let you see me struggle. Tell me if you enjoyed me struggling, or whether I should have paused. Alright, I'm gonna... the clip won't work in this state, I don't think. I'm just gonna have to... I'm gonna have to... what I'll do is I'll just put a load of this... paste there. Right. And what I'm going to do, I'm just going to put the soldering iron close to it, and hopefully that paste, because it's a lower melting point. Like I say, it's what I forgot what it was. It's can you see that? I don't know. I don't know what I've got in focus. I've got my wrong glasses on. It says 183 anyway. 183 degrees. So this wants to be pretty well lined up. I'm just gonna try soldering it and see what happens. I'll put it that way so it all runs it down. Actually, it nearly went to plan. Put some heat back there. Actually, if I could just keep it warm, get it lined up and held in place with the soldering iron. held in place with the soldering iron. Now this, oh, it's still on piss. Actually, I think it'll straighten. Then if I just clamp it with the, and take the soldering iron off, tell me that was on camera. Was it bollocks? Shit. Right, I'll try and do it the same with the other one. Try and keep it on camera this time. Let me just have a look at that. I think that's going to be alright. Yeah. Right. So this time, let's try and keep this on camera. Are we in focus? Are we bollocks? Right. I think that's the best I can do. Right, so what I did was we put this flux that I've made, this solder that I made, so this, we've got a bit of paste on there. And then I grabbed the piece to go on. I'll swap hands. So that piece sat on there like that. Just needed to get it somewhere close. Get my hands around the camera. Right, so that goes there, and then what I'm going to do, I'm going to stick my soldering iron on there and hold it in place with the soldering iron until it's in the right place and the solder's melted. Then I'm going to grab it with the tweezers, and hopefully the tweezers will keep it in the right place. So on with the soldering iron. Let's just hope I'm staying in shot. So there's it in place with the soldering iron. He says. Then he tries to change hands and grabs it with the... And I haven't got it with the tweezers. Right, I think that's right. Grab it with the tweezers, let go with the soldering iron, hope that I'm in shot while it cools, and then let go with the tweezers, and it should be on there. Right, hopefully that's got it. Right, I'm just, what I've got here somewhere. Right, these are, the batteries are 4mm diameter. What I've got here is a drill bit. I just got it there for the shaft, which is 3.5mm diameter, because I want it slightly small. Because spring, when you try to bend something round something, it springs back. It's got a bit of elasticity to it. So to get it to form to the shape you want, you've got to get it past its elasticity. So we got that in shot, right? So basically, I'm forming this around. Can I get it on the camera? I'm trying to form it round this. Hang on, I haven't got the best cameras, and I've got my wrong glasses on, so I can't tell whether it's in focus. Yeah. So what I'm trying to do is now form those. I've got my 3.5mm bit, and I'm trying to form them around this this drill bit. So I'm just going to pause because I'm going to have to do it off camera anyway, because I can't do it the way I'm doing it. So I'll show you when I've done. Right, there we go. Let's see if I can get that on camera. So let's get the side view. So get it in shot, in focus. So yeah, so one soldered on one side, on that side, and it curls around, and the other one is soldered on the opposite side and curls around. And if we look on the end, you can see that I've got them. So where's my tweezers? So where are we? This end here is soldered and it curls, so it's got springy, and then the other one on this end is soldered here, it curls around and is springy. Actually, the fact that the gap in the battery worked out alright, actually, because these actually curl around inside the PCB, and this one curls around inside that PCB, and the battery fits inside. So let me just show you the battery fitted. So let's just see if I can turn it and keep it in focus on the where are we? Get a bit closer. There we go. Is that? Let's try and get some lighting better. Is that? Oh, there. Have I got it? Right. Yeah. So let's see. The battery comes in, goes in there, and pokes into there, and that's it. There we go. Yeah, so we've got a band around the positive. Oh, hang about, I've totally pissed that up. Trying to do things on camera, have I messed it all up? Yeah, there we go. Hang about, I'm just gonna forget the microscope for a minute. I need to see it. I need to actually watch what I'm doing. There we go. Right, the battery's in the correct way now. So where's my microscope? There we go. So what we have is the bottom one going in through that clip, which is sandwiched between them two, like so. There's no focal depth on this thing, is there? And then the top one goes through that top spring ring, like so, and it goes through. So yeah, there we go. Looks okay, does that? Well, look at the bottom one down here, and if I press the button, I don't know if you can see the light. No, you can't. Hang on. Where are we? Get that in focus. I wonder if I can focus out a bit further down here. Let's see if I can. The thing is, right. How's that? That's a bit better. That ain't too bad, is it? It's a bit better than it was. There, so you can see the top one going in. I just need to trim that edge off there on the bottom. Actually, I'll do that now. Let's use some side cutters. Try and get closer than that. I might use a file or something. I don't want to try and too hard. I might end up breaking the PCB. Right, so what can I get in shot on the microscope? Right, so there we go. I've got that, so I've got a button. Let's try pressing the button and see if the light can show on the is that not lighting? Hang on, let me just turn the light off. How's that? Let's try and get that in focus. There. Press the button. I don't know, can you see it lighting up the LED? I don't know. Right. I haven't got that in focus. Tell you that the focal length and the refresh rate is so shit. Right. Can I get the button in shot and the... Can't get the button in shot and the LED. There. Hopefully you can see that. Oh, you can see it down below. Yeah. You can't see it on the so much on the yeah. Press the button. Right. I'm going to leave the video at that. I've got that bit done. I just need to let me turn the light on. Let me just pause a minute. Right, let's just sum this video up because it's been long, and if you ever made it to this end, congratulations to you. Thank you for actually watching all the way. Let me just move that. And I'll just move that over there. Right, so that is my little thingy. It got a button and it lights the diode. Lights the LED. Oh no, you can't see that. Don't know if it lights up on camera. Anyways, right. So I just need to test it out now because I messed up with my prototype. Right. So remember my work of art. Yeah. Can you see how long all these wires are? You see, I've got all these long resistor wires and such like. Well, basically, they're like bloody antennas, and my bench has got a lot of mains frequency, mains frequency around it. Sat here, I don't know if you noticed that when I was touching my hotbed with my my tweezers on the hotbed, you'll have heard, if you go back and listen, you can hear a bit of buzzing as it touches, and that is the main static that's getting picked up on my microphone and what have you. And when I made this prototype, I forgot to turn it on. I forgot to wire up what pin it was. Hang on, let's have a look. I don't know how. This is why I couldn't figure out why I was getting 50 hertz. But you see pin 4 here, the reset pin, that needs wiring up to VCC, and I forgot to do it. That meant this was floating. And so, because of all the wires and everything on all these, they were acting like, and because the current, you remember I told you that the current drawn by this 555 is very low. It takes the slightest amount of current to turn it on. And what was happening was the interference from the mains AC on my bench here was actually turning it on and off, and that's why I was getting the 50 hertz. So now I've got the PCB and no long dangly wires on it. I need to do a bit more experimenting. I need to make sure that the frequency that comes out of here is the frequency set and not whatever it's picking up around on my bench. So yeah, have a good laugh, because I just couldn't figure out where it was. But basically, because it needs you just need to look at it to turn it on with the low current, and the interference from around the wiring was actually turning it on and off, and that's why I was getting 50 hertz out of the output. Anyways, so there's going to be another video once I have sorted out my mistake with this one. The other one's fine, of course, because the other one's just an oscillator of two transistors. But it's one thing you've got to watch with the small, low-powered stuff is interference from a surrounding area, and I learnt the hard way. So yeah, making a work of art with about 20 aerials on it, antennas, is not the way to go. Okay, thanks for watching, guys. I'll catch you in the next video.